Hang on. We're adding you to the class. So if you look, you'll see someone adding you to a group. Just join and you'll see the link. Well, I need to do it again because you probably won't see the link. No. Join to the group that we're joining you on WhatsApp, and then you will see. I'm gonna drop the link in again. Okay. All right. So I'll give him a few minutes, but okay, let me just resume. All right. So you guys ready to, someone ready to explain that one for me? Let's move back to this slide. Where are we? Okay, this one here. Can somebody explain the first one for me? Thank you, please. Tell us how we get the components. All right, so who's gonna explain that one? Do I have to call on someone? Only Kendrick alone and say unmute. Abigail, what about you? You want to tell us how you get the first one? Abigail, you with us? Anis, who's gonna explain that one? Monique? Hello, are you guys hearing me?
Yes, I'm hearing you, sir. I don't know what to explain, but
Pardon me?
I'm hearing you, sir. I don't know who is going to explain, but it's not me.
You're going to try.
Sir, I don't know if you explain, sir.
I'm saying this one. All right. Let me.
You can try, sir.
Yeah, for the first one. First one over here.
All right,
I guess them component here.
All right, I guess for the component, the resultant in direction, that would be it acting the negative coordinates of x and y. So for force for force and the x coordinate would be force times sine beta, right?
I mean, if you look at it now, how do you know that the x for the x? I mean, all right. Let me help you a little bit. Let me see if I can help you a little bit. All right. So what you do? One of the interpretation is this. You could see the right angle here now. Is that better? That help you better? So what you do at the y, you construct a right angle there, and you can see the 90-degree triangle. So if we see if I can draw it here now. Wow. Man, lean man. All right. So let's see. So we see in the y, it's almost like the y is so the y would be, let me see if I can visualize it further.
You see, I'm right up on the top. The y would have be no.
The y
would have been right at the 40.
Right. So therefore, Right. So this will be the X and this will be the Y. Correct? Correct? Agree?
Yeah,
So
yeah.
we're saying that, so would we be saying that the beta is up here? That's a question I want to ask you.
Yes,
Would we say
sir.
that the beta is right there? If you to see it upside down, would you say that the beta is there? So this is the Y and this is the X. Who don't agree with me? Is that correct? Yes or
Yes,
no?
sir. I said yes, sir. Yes.
Good. So and where's the force acting now? The force is going from B up. Is it the force coming this way? Is that the force going that way? I'm asking, is it going that way?
Yes, sir.
It'll go towards the X. It'll go towards it. So I leave from yeah,
Yes,
it'll go
sir. How you
towards
draw
it.
it? Correct.
Right. So good. So what we're saying here now, so the X, so the X component is going this way, is going to be what now? So it's F. So in other words, this is the hypotenuse. The F is the hypotenuse. All right. And let's check the ratios then. So you're going sine of beta is equals to what now? The opposite, which is the f of x upon f. Agree? Is that how you interpret that one? And what about the cos? Cos of beta would be equal to what now? So the cos now is a side beside it. So this is a component. This is f of y, while this is f of x. So it says it's the adjacent side upon the hypotenuse. All right. And when you resolve that, you're gonna get f of y is equal to cos f cos b. All right. So that's how you look at it. So this is just simply saying is resolving them in the components them. So you resolve them to the y and resolve them to the x. That's pretty much what that one is saying. But the first thing you have to approach here is you're able to visualize it. So in other words, if you drop another line here, so you could say that this is beta also. So you could view it from that angle also. So you could see the Z angle and be able to write them. So this one is here now, you could say that is f cos beta from this direction here, and from that one is y, because that is adjacent at the side there. So you could say that this is f cos beta for this side right here, because it's adjacent side that. All right. So you have to be able to look at them and see them. All right. What about this one here, the number 3? And the one the number, so this is A, sorry, B, C, and D. All right. Who want to explain? I'm going to erase again. I'm going to erase everything that I've done there. Where's the erasing tool? I'm going to erase here. Can somebody explain the rest of me, the next one?
Here, mega try.
Let me lose this eraser here. Oh, eraser, see if not wanting to go. Where is it? Stay. All right. Yeah, go ahead.
Sir, you could construct a right angle triangle from the starting at the red line to the X.
That way?
Yes, sir.
Would you construct another one? Let me just help you. Will you put another one there? All right. So if this one is, if beta is there, so where else do we have a beta here? For visualization. So you could have a beta from that angle also. Okay, you notice the parallelogram a force is being showing you there. Right. So you will see that if the force is going down this direction, so it will be one going that side, that way. This is also important. Or force coming that way, going that way. All right. So you see the directions. All right. Go ahead. This is X, and this is Y. All right. Go ahead. So the components that we're talking about, this is f of X direction, and this is f of Y. Go ahead now. But you must notice when they are minus, you notice the direction that they are going into the minus. So I just put that for you. They're going to the negative direction. Continue.
Sir, me don't know what else to do, sir. Me don't gonna know the part there.
Just tell me how you get the minus f of cos beta and the minus sine of cos beta. Tell us how you would visualize it to get it. That's what I want. Do I need to clear the diagram? It look a little bit crowded. Let me clear it up a little bit.
Sir, hold on.
Maybe a little bit crowded there, so I'll clean him up a little bit there. So a little bit better. This is beta. All right. Yeah, go ahead. Can you see
right.
it? Can you see the what I'm saying there?
Yes, sir. All right, so fx, that would be well, from beta, fx.
Which triangle are you using, by the way?
All right, I'm going to use hold on. I'm going to use the fy.
This one out here, so?
No, over the next side. No, the one right up, the top right over here, so yeah, the fy.
Right. So right, so you're putting the right angle right there, so.
Yeah.
And this one you have right angle here.
So in regards to beta now, we would have that would be opposite. Yeah, would be the opposite angle over the
opposite
adjacent
side. The opposite, you have the angle.
Yeah,
Opposite
side over the adjacent. Yes, so that right there, so.
Yeah.
So that would be sine.
And this is the adjacent side.
Yes, sir. So for the fy, you would have f sine beta.
For the f what?
For the fy, you would have negative f sine beta.
Why is it negative?
Because all right, the direction of the force is going to the negative coordinate of negative y and negative x.
Right. So positive is that direction, but it going opposite direction, it going down.
You're right.
And for the what about the f now?
For the fx.
fx.
Yeah, for fx.
Yeah.
All right. In regards to beta, the side that we are looking for now would be adjacent. So that be adjacent over hypotenuse. That would be cos. So it would be negative f cos beta for the fx. For the force.
Why negative? Again.
All right. The direction of x is going in the negative as well.
Okay. All right.
And when we say negative, that would be for the x coordinate, that would be from 0 to going downwards. No, sorry. Why I go downwards? It'll go to the right. It'll go to the right. That's all. Oh man, one left memory, I right. Or to the right are the positive and to the left are the negative. Correct, sir?
Pardon me?
No, man, I was just trying to remember the positive side of the something, the coordinates is to the right. So the negative would be to the left.
I would prefer you look at the direction of where the arrow is going on the diagram in front of you and classify it from there. So don't do it that way. Look. You see the X here, sir? the arrow is pointing. In order for the resultant to be acting through O, it means that you're going to come down virtually here, you're gonna get negative Y and negative X right here and here. So it's going in this direction. So therefore it come in this path. Look at it in that way to visualize it. And for the Y is the same thing, coming in this part to the negative. So, right, look at it that way. If you look at it in a way, you look at the diagram and say, I don't have to remind anything because you have it right in front of you. All right, so, and that is how you resolve it. All right, somebody want to take on the next one? I can help you by drawing, breaking it up into right angle triangle. Let's see if I can help. All right, I'll just drop some lines down. Somebody see if they can pick on this one. And what is pi? Pi in radiant is 180. But remember that? So that will help you. So the angle between here to here is 180. Right. So that's what we call it. So that's why I call that pi. So the difference, so if you want the angle here, that angle here is going to be 180. Sorry, pi minus 180. 180 minus the beta. But the 180 is known as pi. Right, so that's what they're using there. So don't use that trick. How do you resolve here? Is this one easy? It's just the angle alone is the hardest part. Right? Which you just see what they write there. So that's using that to trick you. But it's the same stupidness. Anybody else want to break it down and tell you what the result get it? It's pretty much the same thing that you have here now. Only thing that they put the angle outside here. They gave you the angle outside here, but you need the angle inside. So, which is this little part here. But of course, one is positive and one negative. Which one is positive and which one negative? And how did they get one positive and one negative? Why? Go in that direction. So if you draw the arrow and you get that one down. So in the X it is positive. And in the Y it is negative. You can clearly see it there. And that is why it is so. So this is positive Y going that direction. Positive X is going this direction. And this one is certainly going this way. So with this component here is positive. And while this component is negative. That is the difference between this one. All right. And you just resolve it using that right angle triangle there, because you have the angle already. So theta is equal to 180 minus pi. You resolve it. The component, this side here is adjacent and this side here is opposite. So adjacent, say just write it. So now remember, once it's adjacent, it's cos. Once it's opposite, it's sine. So remember that. All right. So right here, so you need to be able to look at it and resolve it. So you know that is f, and if it is going down, it is positive f x sine theta, which is equal to what? Pi minus beta. And the other one is going this direction, which is cos. So this is minus. All right, because it's going here. So that is also looking and able to look at a right angle. So let's put it here again. And this is very important when you're doing complex problems. So you have a force here. You may have, all right, you may have this here, and you want to write the angle for the various sides. Right? So this is, let's say you have f of x, and this is a f of y. Right? This is 90 degrees. You must be able to look at it and know that this is equals to I think my internet just did something, disconnected me. Let me see if I can get back on. Are you all with me? Yeah.
Yes, sir. When you say adjacent, what's this?
Hold on, let me get back to
discuss?
the slide because it kicks me off. I think my internet just kicked me off and I'm back. Are you with me now?
Yes, sir.
Mm-hmm. Yeah.
Yes, sir. Everybody is
Deep
here.
a while. Like it deep a while ago. Yeah. So this is adjacent and this is sine. So look at where the angle is. So there are two focus I want the class to know. Hold on, let me go to a different page. I'm gonna drop this page and I'm just giving a little review. I'm gonna discard this and hold on. It's telling me that I can't minimize. Hold on. I'm gonna find a way. I'm gonna stop share. Let me stop share. Did I stop share a while ago? Yes, I think I did. Let me go and I'm going to reshare. Hold on. It's telling me. Why is it telling me this? Hold on. Let me reshare. This is going on. Let me reshare. Uh-huh. Okay. All right, let's reshare. Okay. Now, remember, let me see if I can pick. So you have an angle here. Let's right. So you have a force here, and it is to the horizontal. That's two components. You know, but you have y and you have x. All right. What I'm simply saying to you now, class, there's a component of x to this side and a component here, which we have dealt with already. You know, this is right angle triangle. Once it's this side and it is, you see the angle is sine here, it is the opposite side. So this component is always going to be Fy sine theta. While this one is a cos, which is on adjacent side. So it's going to be Fx cos theta. That's all I'm saying. So for when you're resolving forces, you won't have time to go look and is this a beta or whatever. You must be able to recognize that once the angle is lying beside the side, it is an adjacent. Once it is lying in front of it is a sine. You're gonna get a lot of problems and nobody gonna have time to say, we're just gonna say that. If you're resolving this, this is gonna be F cos 30, and this one component is gonna be F sine 30. That's all we say. You must be able to look at them and know them, right? That is all I'm saying. So let's get back to it. Hold on. What is happening here? Okay. What is this garbage here? All right. So those are pretty much it. This one here is a little bit much trickier than one before, and you should be able to visualize it. Now, anybody want to dare to explain this one? The last one, D here. Can you see it? Are you seeing what I'm looking at? Let me go again. Maybe you're not seeing. Hold on. Where's my slide? Are you seeing this? Anybody want to dare to explain this one? It's beta minus alpha. Anybody want to dare to explain that one for me, please? Yes or no? Maybe so.
No, sir, because me not fully get it.
You don't fully get it. I'm saying, anybody understand this one here? Nobody understand it?
D your talk, sir?
I'm talking the whole class.
No,
This
me
one,
ask
this
you for
one, D
question
here.
D.
Yeah, man, D part. Are you seeing where I'm at?
Yeah.
Let me go full screen so that I can get that right up. So we could do a number of things here. You remember we talk about sliding forces? You could slide this one too, you know. You'd have to slide it, you'd have to look for the angle and slide it down. So if you put this slide this force down. So we could do it a number of ways. Let's see if we could do it this way. If you slide that force down, slide it down on this line here, the same one here, F. So it will be acting somewhere from the center here, that line. So that angle would have been alpha, also that angle here, while this one is beta. All right. So if you did that, that's one. Let's see if it could work that way. And let's say we drop a perpendicular this way. That's one of them. Let's check it.
Sir, you put it in wrong, you know, sir.
Where? Which
The
one?
alpha is supposed to be on top. It's
Alpha is
supposed to be,
the alpha is
yes,
up
yeah,
here.
yeah, it's
This
supposed to
is
be
the
on
F.
top.
I'm sliding the F down.
Yeah,
Sliding it and call that F now. So I'm sliding it down on this line here.
yeah, it's supposed to be on top, not at the
Yeah,
bottom.
sliding it down here.
Mhm.
I'm sliding it right down here. All right. So I still have this force here across here. So, but I'm sliding this force here. See this red one here? I slide
Yes,
it
sir, I
down
see
here
you
now.
sliding it, but what I'm saying, I
Mhm.
doubt the alpha that you are, where you slide it,
Mhm.
it is right. I doubt it is right. It's supposed to be on top of the line.
Oh, you're right. You're right. I love that. Says this one right here. So hold on. Come on, writer. Writer not working. Come on. Oh, hold on. What is happening here? Discard. Hold on. What is happening there? Come again. Are you all here? Because my internet seems to be playing games on me. All right. So let's drop it down here again. We slide it down and we put it here. All right. All right. So therefore, we're saying that this is the alpha. All right, perfect. All right, if that's the alpha, then we're gonna drop a, let's see if we drop a line here. So this is our y. This is still our x. So we get beta minus alpha. So it's with this line here now. This little section right here, so it's going to be what? Beta minus alpha. We agree? We agree? This
Yeah,
little
man.
section
Yeah,
down
man.
here. So.
Yes,
Yeah,
sir,
man.
I agree.
Right. Good. So from that now you can resolve your forces. So this is F, which is hypotenuse. And you have a component. So if this is what? This is hypotenuse, this is adjacent side, and while this is opposite side. So this is sine, but is the force positive or negative? Which way the force going? That way. So therefore the force is positive in the y and positive in the x. Am I correct? Agree?
Yes, sir.
Good. So therefore, that is how that way. So this is a sliding. Do you remember talk about transmissible force and sliding vector? So we slide it down to here. What is happening? Now you're right, the angle is up top, not on the bottom. My labeling was wrong. And this angle, right. So the difference between the two angles will give us this little one down here, which is beta minus alpha. And all you do is using resolution of forces. So the component of the force down here will be F cos beta minus alpha for the x direction, and for the y is F sine beta minus alpha. So that is just showing you how to when the angles are acute and they're not the regular way, try to form right angle triangles and do the resolution of forces. So let me go. Am I going backward or forward? All right, so here we have them. So what they're saying is vectors again. So you know vectors can be resolved, eh? And you know about identity of vectors, so you can say that the vector v, big V, is equal to small v cos of the unit vector plus the sine of the unit vector. All right, that is one. You could also have it worked out in using what we call more Pythagoras and unit vector combined. So we do here, you look at it, if you use Pythagoras theorem to find V, you would get for 4, it will be 4i, and for the 3, it will be 3i, right, using Pythagoras theorem. And when you take the Pythagoras, for the magnitude of it now, right, which would be the 4 square plus 3 square, which is the actual Pythagoras, that is helping you to show you how you get unit vector. All right, and we're gonna use these principles coming up. So so these principles are going to be used. So you get a unit vector out of this. This show you how to break down, move a vector from what we say now, from coordinate form to unit vector form and vice versa, right? And this one is using the angle. So this is using the ratio, that one is using the angle. How to break it down into unit vectors and break down the vectors into to unit vector and so forth. So this is just showing you how to move from one form to the other. Now these are polar coordinates. How you use a polar coordinate, pretty much the same. You would have to subtract these at one point. Oops, slide running away. So these are polar coordinates, are what you call coordinate, right? So you're subtracting the x component from the y component. Every time I try to write on it, it's gone another direction. Why is that happening? So, right, so let's go with the stylus again. So the component here, you look for the x component, and what will and the y component. The y component here will be 6 minus 3, and for the x here, so it would be what? 9 minus 2, right? So the x component, they use the same Pythagoras theorem, same principle. So this component here is giving the x, that component giving the y, and you use the Pythagoras on the bottom. And what you really have in here, so it's a scalar part of the vector times the unit vector give you the vector. All right, so and that's what it's break down to here. So this is more the scalar form, and this is a unit vector. This is a vector, this is a scalar multiplying the unit vector. So all of this give you what we call a unit vector. Right? So this is a scalar form of the vector multiplying by this is more the directional part of the vector. Right? So this part is the directional part, that is a scalar, end up to give you the vector. So if you want to move from one to the other, if you want the scalar part of the vector, you have to divide the unit vector by the vector itself, and vice versa. If you notice what is happening here, but what they're showing you here, they're showing you in the trig form, they show you in the ratio form, and they break it down into the coordinate form of the ratio. So that is in 3 forms. So when we talk about position vector and all of these, this is very important. All right. And here now we have a very simple problem that is fully worked out. So we just quickly look through it. So here we have what you call now, it says determine x and y scalar component of f1, f2, and f3 acting at A. And what kind of force is passing through A? Can somebody tell me on the bracket? I'm waiting. What type of force is passing through that point? No answer? Class, what force is passing through the 3 forces? What point is that? We just said it a while ago. Several examples. Several examples. What is that point? Are you all not hearing me?
Hey, what force is passing where?
Hey, what is the point? What the 3 forces are passing through that point. What kind of point we call that? What in terms of the forces? What the forces pass through the common point? What do we call them? What? What? I heard something a while ago. I'm trying to see if it's the right thing I heard.
She says some more restoring force.
What about the point? There was the name of the point. We went through several slides and I mentioned a particular point. When force pass through one common point, we said that they are a certain type of force. What we call them? Anybody want to tell me? When forces pass through the common point, what do we call them?
Concurrent force?
Exactly. That's all I wanted to hear. That's all I wanted to hear. That's all I wanted to hear now, guys. Not more than that. All right, so what we're doing here, they say you must find the component of the forces. All right, can anybody tell me how to solve this problem here? Anybody want us to walk us through it?
Sir, what me know is that from A to C go draw one line go up get a right angle.
From where? Which one of the forces you're talking about? There are three forces. Which one of them?
F1.
Okay. So for F1, you draw a line. All right, I'm going to draw that line here. I assume that you also have a line here. That one.
No, sir.
And I can draw one here for you. All right.
Okay.
All right. So all of those I can break them down into right angle triangles. So you can see how it is resolved.
Sir, well, since I do that, what about, I'm not sure if it's correct, what about like drawing from the A go upwards?
No, well, I mean,
And
all right, if you draw it over here, go up. All right, let's draw this one. So you consider that that's where your F would be? That's why you consider where your F would be?
well, yes, sir.
All right, I put it there. Doesn't matter, seriously. All right.
And then, sir, that the angle in there, so
That's your
yeah. And then the angle right there, so would I say would that be a what 55?
Pardon me?
I'm saying the angle right there, so from the X come to the, I don't know if I explain it, sir. The angle right there, so would that be 55? Beside the 35?
You mean this will be 55?
Yes, sir.
What do we have to bother with that?
I don't know,
I want
sir.
the component of F1 force. I want the component in the X and component in the Y. So I want F of X1 and I want F of XY. Can you tell me the component of them, please? All right, let me just put them F1 and F1. Oh God, F1X. Yeah, and F1Y. Yeah. Give me the component.
Yeah, but cost 35.
F1 cost 35. Right? And in other words, we could write this as 600 cost 35.
Yes, sir.
You understand what I'm saying? All right.
Yes, sir.
All right. Can you tell me the Y1 now, please?
Sir,
Yes,
no,
sir.
at that time the would that be 55, so that'd be
Why you going to 55? You have 35 already, don't waste time. You have 35 I work with already, no matter waste some time. If you see one angle, don't find the other one. Just work with one angle and don't confuse yourself. You understand what I'm saying? Don't bother
Okay,
come to this one. You have one already, you waste time. You have that one already, work with that one. Is it
so
same?
that'd be sin 35 then.
So it will be, so this is F1 times that, and this is going to be F1 sine 35, right? You don't waste time. Or in other words, you could write that 600 sine 35. So you have two components here, and they are positive. Why they are positive? That is going up, that is going that way. So those are positive. So it is 600 cos 35 and 600 sine 35. So you have two components. We want F2 now. One is going in the negative and one going in the positive. Give me the F. Let me use the other side of it. So F2 component in the X and F2 component in the Y. Give me them right now.
Both of them are minus.
No, you give me all of them because I want them to heal that's far further a while ago, I can.
That's not right. That's not right.
It's who was talking a while ago.
Crawford.
All right, Crawford. All right. I know say you're sharp on the butt. I want them to come into to it. Give them a little chance to come into it. I want to see them understand them basically. All right. I'm gonna ask you a question, guys. This is a ratio. This is in the form of a ratio. What would you do here so in a ratio? You have two options. And you can make life easy or you can make life hard for yourself. What would you do right here that is into a ratio? This is 3, 5. So what is the other side of this triangle supposed to be? Now 5.
3, 5, sir?
Yes, and a 3, 5 triangle that. If you see 3, 4, it means the Pythagoras mean that side of 5. Right or wrong?
So
Not sure.
foreign that to my ears.
And then this is going to be, you can call that one theta. Now you just work with one angle. So what is sine? The sine direction, if you see a ratio, the sine is going to be what now? The sine of this one here. Sine is going to be what? Tan theta is going to be what? The ratio is 3/5. And then the cos is what? The adjacent side is 4/5. Do you see that? Agree? But do you agree with that?
Yes, sir. Yes, sir. Pythagoras.
Anis? Blackwood? Are you there with
Sir,
me?
it's foreign to me, so me just a listen.
I'm saying to you that the ratio, if you see 3/5, it means that this is a Pythagoras angle. So you
But
can
on a
have
3/5, that's sir, on a 3/4.
3/4. 3/4. If you see 3/4, it means that the other side is 5. That's what I meant. So this is 3/4, the other side is 5.
Okay.
It's a 3-4-5 triangle. That's all I'm saying. So if it come out wrong, just correct me and say 3-4-5. Right. All right. So all I'm saying that you know the ratio of the sides. So this angle here is represented 3/5 for the angle, and the other one is 4/5. So and F2. So can you tell me the component, please? Now that I tell you that you know the angle, can you give me the components?
Yes, sir. That would have be
Which one are you doing first? X or Y?
the X.
Yeah, give it to me, please.
So it would be 500.
All right, okay, all right, fine. 500 times,
Sine 3/5.
we know a bit sine 3/5, which is just 3/5. You agree? Because this would be, you could write this as F2 sine theta, which is equals to 5 times, and this is 3/5, and that is 5. You agree?
Okay.
Because the ratio of the sine.
Okay.
The next one from that, give me the next one for the Y.
Well, basically with a big cos.
Cos, yes. Cos
4
theta, and this is F2. So it will be there for what? Give me the numerical part of it now. It will be what? 500. And what's the
Times
part?
4/5.
Is all of them positive? Is there one negative and one positive? Which one should be negative?
The X.
Why?
The X should be negative. The X should be negative.
Good, because it's going in the negative direction. All right. So all you do, you'd work those out. So this is one is 5 times 3/5, and the other one is 5 times 4/5.
Okay, the markup where do this is, sir. Robert, erase it, sir, so we can get a screenshot.
Hold on.
Kind of confusing.
Sir, what is the duration of this class?
This class really finished today. It finished at 8 o'clock. It's normally, as I said, the class is supposed to be from, is it really, the time that they have is 5:30 to 7:30. But I have not discussed with the class in terms of if that time is convenient for everybody. If 5 o'clock, 5:30 is good, or you want to move it to 6. 6 is not bad for me. 6 to 8, whichever is better to help you, and for as long as you're not having a clash in any other course.
It's only on Wednesdays.
Wednesdays and Thursdays. Thursday is 7:30 to 9:30.
We can discuss the timing, sir. As it relates to the ratio thing, that's as far as it can get with the 3-4-5 triangle.
Yeah, there's another one, but this is one of them. This is the basic one that we normally use. And we use another one too. It will come up in problems.
Is it a case where we could get like 4-5 and we should know that is a 3-4-5 triangle?
Well, you have you say 3-4, so you know that is a 3-4-5 triangle. Remember that's all I gave you? 3 and 4, you know.
Sure, right.
And when you use Pythagoras theory, you get the other side. The 5 represent the hypotenuse. You saw that, Anis?
Yes, sir.
It's Anis I'm talking to, right?
Yes, sir.
Okay, I was trying to remember the.
Sorry if you know me, but I know you, sir.
Okay,
Okay.
all right.
You said this today is 8:30 or 8.
8 is really 8. All right. But we start a little bit late, so all right, I won't kill you. The triangle here, that triangle they have at the bottom there. That side. Someone want to take on that one? F3. You notice that you don't get an angle, correct? How do you approach this one? Can somebody tell me how you approach this one? It's workout behind, you know. I just want to pick your brain. This slide is
Sir,
workout. How do you appreciate this one? Tell me about this one.
I will use pi and find out the angle.
All
And then
right,
give
we'll find out this angle here.
uh,
Right, because you have the length of this side. You have a length of this side, and you have a length of the side to here. Right. You know this side here is 0.2, and you know the entire thing is 1. So you know that this is 0.2 also. The height from here to here, we know because this is 0.3, that is 0.1. So we know, so that triangle is like this. Is what, 0.4 and 0.2. So from that, you can find out that angle using your trig ratio. Right? You could use tan. So the tan is what? The opposite upon the adjacent upon that. So it's the tan of 0.5. Tan of 0.5 is what? What is tan of 0.5? I don't know if I have my calculator. What is tan of 0.5, someone?
sir, hold on.
I wonder where's my calculator. You know, I haven't seen my calculator. I have to go look for it. I really have to look for it because I haven't
sir.
seen. Yeah.
Sir,
Mhm.
I got ask you, excuse me, I'm having an engagement.
All right, go. All right.
Sir, 6.9.
What? 6.98
98 or 7.
is that correct? Make
We
sure
don't know,
that's the
sir.
one. Is the inverse of that you must find, by the way. The
The
inverse,
inverse with an.
yeah man, is the inverse of the 0.5.
Hold
Tan
on,
inverse
let's
of 0.5. So it's not tan, it's tan inverse.
0.5.
Second function,
26.56.
so it's 26.6.
I just said 27 then.
So that's the angle. So it's really the tan inverse of that. All right. And therefore, you just simply resolve the forces to the horizontal and you get the two components. Let's look at how they do it down here. Right, as I said before, it's fully work out, but I just want to pick your brain.
Sir, may I beg you to do something for me? Go back there, sir. Go back.
Fully work out.
Put the inverse sign this because I'm gonna take the screenshot so I can review.
Tan inverse of 0.5 equals 26.6.
Okay.
All right.
All right.
All right. So, right, so see there, fully worked out again. To see the angle there, and you just simplify the ratio of the other. So, and as you find the ratios, remember, you can sum them and use Pythagoras theorem to find the rest of it. So you sum all the ratios together. You can do it different way now. So this problem here can be done in another form. You can use unit vector. What this side here, they say alternative solution. What they have done is use a unit vector approach here, which is a little bit more complicated than the one before. You can look through it. And if anybody have any question, we can go through it next class. And say another approach here. Say about 2 to 3 approaches to doing the problem. Right? And this is the one that we did before. See, it also worked out here with the univector approach. Right? So it's not right. So these problem, all right. Let me see. So I have that one there. So this one fully worked out also. Same approach, same thing. And it's fully worked out there. An alternative way to do it, we using the unit vector. So the slides are pretty straightforward. Right? Where are we now? Is this slide finished? I think we're finished here. Let me see, we still have this one. All right, all right. All right. So you can try this problem here. Right? It's actually, you see, the solution is here. Okay. Yeah, the solution is here. Let me see if all the solutions are here. Yeah, everything is pretty much worked out here. All right. And this one. All right. So this one, this is your first classwork. This is your first assignment. Do this one. All right. So everybody must, this is one of them. There's a lot of them, but that's the first one. But you need to work that one. Your first assignment. All right. So that's your first classwork.
All right then, sir. See you next class.
All right. Good, good. Have a good evening.
Okay.
All right.
Same to you, sir.
All right. So we'll have to, we talk about the videos. Right, I'm sorry, I don't think I'd start recording this one earlier. I may have to use another video for another class that I've done. So
Yeah, they start recording this, sir, but never wasn't for long.
this recording capture the first part of the notes.
No, sir.
It's a little late, all right?
Okay. All right then, sir.
Good, good.